Good afternoon. Salam alaikum. I would like to welcome to this technical session number 6, which is on the emerging IoT applications. So in this session, we have before the break, we have actually a presentation schedule. So, I would like to welcome you all for this session on the emerging IoT applications. So let me now cordially invite Mr. Ankit Dubey to present his paper titled An IoT-based framework for adaptive fitness recommendation using clustering and ensemble regression. So this presentation would be presented using the recorded video. So let me start.
Good morning. I am Ankit Dubey and today on behalf of my co-authors, Nafeen Kumar, Ayushman Khanna, Rajesh Modi, Firoz Khan and Ahmed Akhia, I will present our S4IoT25 paper on a hybrid machine learning framework for adaptive fitness recommendations. Our paper ID is 21 and today I will take you through our motivation, methodology, result and future directions. Now moving on to the next slide. Here is the roadmap for our talk. We will start with the abstract and then move on to the introduction. Next, we will state our problem statement, research questions, and objectives. We will briefly cover the literature review and highlight the research gaps. With that motivated our work, then we will dive into the proposed methodology. Following that, we will present the results and comparative analysis. Finally, we will wrap up with conclusion, future work, and references. Next, abstract. In this abstract, we will summarize our hybrid ML IoT framework. First, we segment users by k-mean clustering. Then we apply collaborative filtering to personalize workout and random forest regression to predict calorie burn with R square up to 0.997. We evaluate clustering quality, prediction accuracy, and real-time adaptability. The significance our approach delivers highly accurate dynamic fitness guidance that can boost engagement and health outcomes for wearable users. Now moving on to the next slide. Introduction. We begin by noting the explosion of IoT wearables, smartwatches, sensor-laden apparel that captures real-time psychological data. However, most fitness apps still use static one-size-fits-all plans. Basically, what we are trying to do here, we are basically dividing every plan for everybody. Like it must suit everybody personally. Now, our study is motivated by the need of truly personalized coaching, a system that continuously tailor workout based on each user's evolving activity profile, thereby improving engagement and long-term health outcomes. Now, moving on to the next slide. Problem statement / research questions and objectives. Our problem statement is straightforward. Current fitness recommendation system lack dynamic personalization based on real-time behavior. Relying instead on static profiles and basic metric, we ask, can unsupervised clustering groups use effectively by activity patterns? Can collaborative filtering enhances personalizations? Third, can assemble regression improve calorie burn predictions? Fourth, how can we integrate this method for real-time adaptive recommendations? Our objective follow, design the hybrid framework, segment users, personalized workout, predict calories with high accuracy, and implement a real-time adjustment mechanism. Now moving on to the next slide. This is our literature review basically. In our literature review, we cover prior work on activity recognition, recommender system, and ensemble method. We bow an entire and exchange-based recognitions. Korea et al. If we must go in it, the matrix factorization of recommendation, variant random forest. We also review mobile health feedback systems like my behavior and reinforcement learning approaches to fitness personalizations. Now moving on to the research gaps that motivated our research or basically our study. Despite these advantages, gap remains and most systems don't combine clustering, collaborative filtering and regression in a unified real-time framework. Few achieve both high prediction and accuracy and dynamic adaptations. Our work fills this gap by integrating all three components into an end-to-end pipeline for wearable-based fitness recommendations. Now moving on to the next step, 8, methodology. As you can see the flowchart, this is the flowchart of our basic study that we have done for research. In this flowchart, you can see the data ingestion and cleaning. We collected 100K records, handled missing values, activity log for fitness, trackers, and basically with forward-backward fill, retaining over 99% of records. In step 2, feature engineering, we computed active distance, active intensity, weighted kilometer, and calories per step. Then applied min-max normalization to scale features to 0, 1, basically 0 and 1. Now moving on to the next slide. In this slide, in this step, basically we discuss about clustering and predictions. Basically in step 3, user segmentation by K means with K equals to 5 yielding clusters from low to athlete. Profile step 4, calorie burn, prediction using a random first regressor, 100 trees. For example, basically 80-20 test split, targeting the R square greater than equal to 0.92 and MAC less than or equal to 150. Step 5, in step 5, we basically personalize the recommendations by K and N, collaborative filtering, K equals to 10 on normalized feature vector, recommending the top 3 workout per use. As now moving on to the next slide. In this slide, basically in this part of the methodology, we do real-time adaptation and evaluation. In step 6, real-time adaptation, we stream actual versus predicted calories every 5 minutes. In deviation exceeds 10%, we adjust the user's intensity by 1 cluster up or down. Step 7, evaluation and resolution. We plot predicted versus actual calories, compute residual distribution, mean around equal to 0, SD less than or equal to 12, and conduct a user survey, n equals to 50, like n is the number of users, where at least 85% of rated recommendation are helpful or very helpful. Now moving on to the next part, and I have also summarized all of that methodology in this 4 to 3 lines. Now moving on to the next slide. In this slide, basically now we start the result and discussion of our PPT part. In this, I have basically divided the result and discussion as we have seen in methodology in quantitative and qualitative analysis for better understanding. As you can see, the first clustering performance came cleanly segmented user by step and step calorie expenditure. Table 1 shows 5 distinctive clusters: low, moderate, active, very active, athletic, each with clear center differences, validating our segmentation approach. Now moving on to the step 12, and also you can see these cluster activity patterns and actual versus predicted calorie burn. This is for better understanding of this graph or table. Now moving on to the next slide, step 12, result and discussion, quantitative analysis. Here we have done the basic quantitative analysis as you can see. Next, regression performance table to report R to R square score across models. Random forest achieved R square equals 0.9997, outperforming linear and other ensemble methods, confirming its strength and capturing non-linear regression in calorie burn data. Now moving on to the next slide. In our qualitative analysis, clustering insight show that segmented-based strategies can tailor workout effectively. Calorie prediction exhibited minimal error as seen in tight actual versus predicted clusters. As I've shown in the previous slide, the actual predicted calorie burn graph. Collaborative filtering delivered personalized workout suggestions, for example, increasing intensity for users trending toward higher activity, enhancing user satisfactions. Now moving on to the next slide. In this slide, basically we have examined the model behavior. We found ensemble method like random forest and gradient boosting handled outlier and feature variability best. Their robustness underpins the reliability of our real-time recommendations, ensuring consistency even when user behavior fluctuates. Now moving on to the next slide. And this is the basic summary of our result discussions. In this slide, basically, we have like conclusion future work. In this, we have concluded our whole study. The study presents a hybrid of IoT new machine learning approach, as you can see, as you've seen, basically. And now we will move on to the integrating the cluster, collaborative filtering, and regression of delay, personalized adaptive fitness guidance, many of the other things that can be done with the study. And now we move to the future work. In this future work, basically we can enhance the user feedback mechanism, validating the system on larger diverse data set will improve the scalability and applicability across domains. Now moving on to the last part of our PPT, references. Here are the references that I have taken inspiration or basically literature research.com. We acknowledge all the reference works from foundation clustering and recommendation paper to research ensemble learning studies and thank our collaborators and participants. Thank you for your attention. Thank you.
Thank you, Mr. Ankit, for your very interesting presentation on IoT-based framework for adaptive fitness recommendation using clustering and ensemble regression. So I will open the floor for the question. So he's available online. Mr. Ankit, you are available? Can you hear me?
Yes, sir. Yes, sir.
Yeah. Any question? Okay, so I think he already shared with us his email. So if you need any further clarification or if you are interested in his work, so kindly contact him via the email. So I would have a quick question, Mr. Ankit. So I'm just wondering, like, what would be the accuracy level of the accuracy in clustering, and what are the parameters, like, I mean, input the parameters that you have considered in your study?
Basically, exactly which parameter are you talking about?
Like, I mean, for the clustering, what are the different, like, I mean, the health related or the fitness related, what are the different parameters that you have considered for clustering? I mean, type of the data that you have used.
Okay. For clustering, basically, we have gone with like algorithm k means equals to k equals to 5 we have put for the clustering, or low, moderate, active, very active, and athlete profiles. Basically, in clustering, we have used 5 cluster different kinds of clusters: low, moderate, active, and very activities.
All right. So, and so what is like, I mean, maximum level of accuracy that you have achieved?
Basically, we have set the target for 0.92 accuracy. R2 score, basically. And mean square for greater, less than or equal to 150.
Okay. Thank you very much, Sankit. And so I'd like to take this opportunity, like the present for your presentation, and also the publish the paper in the second version of this conference. So thank you very much, and looking forward to your participation in the future conferences as well. Okay, thank you very much.
Yes, thank you, sir. Thank you, sir. Next paper.
Yeah. Okay, so let me now move to our second presentation in this session, which is titled IoT-driven organization and economic forecasting with machine learning. So I think it's the same author, Mr. Ankit. So we'll be presenting. So yeah, let me start the recording.
Good morning. I am Ankit Dubey, and today on behalf of my co-authors Naveen Kumar, Ayushman Pranav, Feroz Khan, and Ahmed Akhiyar, I will present our S4IoT25 paper on IoT-driven urbanization and economic forecasting with machine learning. Now moving on to the next slide. I present my index that contains basically agenda. We will explore a methodology in depth covering data processing, cluster regression model, and anomaly detection techniques. We will then analyze the result and conclude with a discussion on the implications of our finding and possible future enhancements to the framework. Now moving on to the abstract on next slide. In this abstract, our research integrates satellite-based nighttime light data with IoT sources such as smart grid metrics and traffic sensor data to analyze urbanization and economic activity. We designed a machine learning pipeline that includes feature engineering, dimensionality reduction, clustering, regression, and anomaly detection. The model achieves on R-square score exceeding 90%, demonstrating the system high accuracy. This framework has potential applications in real-time urban monitoring and infrastructure planning. Now moving on to the next slide, introduction. Traditional urbanization and economic activity metrics such as GDP and census data suffer from limitations like low spatial granularity and delayed updates. Our solutions combine basically satellite imagery with IoT data to provide more timely and granular insights. Nighttime lights as proxy for development help us classify regions and analyze how urban growth pattern changes over time. Now moving on to the next slide. Basically, in this slide, we will discuss a problem statement, research question, and objectives. Our problem statement is our key motivation is the lack of real-time scalable framework to track urban and economic development. We ask, how can we utilize nighttime lights and IoT data to better model and monitor these patterns? Our objectives include developing an ML pipeline, engineering novel indicators like light density,
using clustering to differentiate regions and training regressors to forecast economic performance accurately. Now moving on to the next slide. Here I basically introduce my literature review. It basically contains the required references of paper that we have taken and done the literature review on. Existing research confirms that night light data correlate well with economic activity. However, many studies either use basic correlation models or ignore added value of integrating IoT datasets. We go a step further, employing machine learning and ensemble technique to develop a more powerful and flexible system for urban analysis. Now moving on to the next slide, research gap. Despite growing interest in urban analytics, few framework truly combine satellite and IoT data for dynamic real-time tracking. We bridge the gap by designing a system that not only models urbanization at a local level but also detects anomalies and trends over decades. This is particularly useful for data sources or data scarce or rapidly changing regions.
Now moving on to the next slide. In this section of our PPT, we will like to talk about the methodology that we have used in this study. And here is the flow chart of all the steps we have taken to reach our end result. We begin with data collection. Our primary source is DMSP OLS nighttime light imagery covering 1992 to 2030. We also include auxiliary datasets like PIRS, population figures, and infrastructure indices. This multi-phase approach allows for a comprehensive assessment of development activity over time. Now moving on to the next slide. In this slide, we will discuss from step 3 to the step 7. And I will start with the step 3. We clean the data set and normalize the data set to account for sensor differences across it. Key engineered features include light density, light per capita, and infrastructure adjusted growth metrics. These features improve model interpretability and prediction accuracy by embedding contextual and spatial intelligence. Now moving on to the next slide. In this slide, basically, our ML pipeline involves a dimensional reduction using principal component analysis, followed by clustering using k-means into 5 urban classes. We then train 5 declaration models, linear random forest, gradient boosting, XC-boost, and CAD boost. Finally, we apply anomaly detection based on polling set score to identify unusual development trends. Now moving on to the results. This is our result and discuss section. For better understanding, I have divided the result and discussion section into 2 sections. Basically, talking in every step, we will talk about 2 things: quantitative and qualitative analysis. These are the basic final types of results. First of all, I will start with PCA reduced the data to a manageable set of principal components that explain about 86% of the variance. K-means revealed 5 distinct urbanization clusters ranging from rural to hyper-urban. This silhouette scores of 0.58 supports the clustering quality. Cluster map shows meaningful spatial patterns that align with known city boundaries and emerging development corridors, as you can see in this figure. Now moving on to the next slide. In this, we will talk about the economic activity prediction. Regression results were strong, with gradient boosting achieving on R square of 0.9521. Nightlight intensity and infrastructure proximity were key predictors. Ensemble models outperform linear ones, especially in capturing the non-linear patterns typical of urban expansion. These results confirm that a framework can reliably forecast economic activity using light and IoT data. Now moving on to the next slide, step 3, anomaly detection. Our anomaly detection identified 11,500 plus significant deviations from over the 30 years period. Many of these align with real world events. This electrification boom of 90s, the economic downturn during the 2008 to 2009 recession, and the urbanization accelerate post 2010. Such insight help policymakers respond quickly to both positive and growth spreads and emerging crises. Now moving on to the next slide. In this slide, we will talk about the conclusion and future work. In conclusion, we have developed an accurate and scalable system that integrates nighttime light and IoT data for tracking urban economic changes. Our models are both interpretable and actionable for future work. We aim to implement deep learning architecture like LSTMs and RNNs to better model temporal dependencies. This will enhance our ability to forecast trends and detect early signs of urban transformation, and much more. Now moving on to the next slide. This is basically the references and basically the paper that we have chosen to do literature review and research here. Our references are wide body of literature in satellite remote sensing, economic modeling, and smart infrastructure. These studies informed the methodology and inspired our innovations in feature engineering and anomaly detection. And thank you very much for your attention on behalf of myself, Ankit Dubey, and my co-authors. We appreciate your time and interest in our research.
Okay, thank you, Mr. Ankit, once again for your interest in the presentation. So let me open the floor for questions. So, any question? All right. So okay. So if you are interested in this work, so please contact Mr. Ankit or the other authors so via email. And so you can access to the full paper once we publish the proceedings. So okay, so once again thank you, Mr. Ankit, and all the co-authors of the two of your papers. And so as I said earlier, so we are looking forward to your participation in the future conferences as well. So let me now move on to the next presentation. The third presentation in this session, so which is on the hybrid neural network for stock prediction, integrating multi-source data with particle swarm optimization. So we have Mr. Harmanjit Singh. So I would start now the recording. So Mr. Harmanjit Singh, so you are available? Can you hear me?
Yes.
Yeah, okay.
Yes, sir.
Yeah, okay. Thank you.
Hi, this is Dr. Harmanjit Singh, and I'm going to present my article. Title name is Hybrid Neural Network for Stock Prediction, Integrating the Multi-Source Data with a Particle Swarm Optimization. I'm going to cover the introduction, literature review, methodology, experiment study, conclusion, and references for this study. This study actually presents a novel approach to predict the stock prices using neural network, which is optimized by a meta-heuristic algorithm, particular swarm optimizer. And for this, we used Bombay Stock Exchange as one of the listed indices, and we received the blue chip stocks which are listed on a BSE. And for that, we also use the historical data along with the technical indicators such as volume, volatility, trend, and the momentum. In the neural network, we use a long short-term memory because it has potential to attain the longest time series data. And we used along with the multi-head attention mechanism to capture the temporal correlation in a technical indicator. For valuation, we used coefficient of determination R2, which we received 0.97 for our framework. And the second one is MAPE, which is for 1.67 for stock Larsen and Toubro, which was tested on 200 epochs and a learning rate of 0.001 with our meta-heuristic algorithms. And at last, we achieved the accuracy of 89% accuracy when we trained our data on a 5,000 trading day on one of the stock. In the literature review, the first study which predict the fuel prices using meta-heuristic LSTM model, and they use the particular swarm optimizations. And they have used Yahoo Finance and US Energy Information Administration, which provide the weekly statistics from the Jan 2000 to May 2024. And the key indicator was the construction jobs, crude oil and gasoline prices, and with the S&P. They fuse the two data sources. And the lag window of 5 days, and they predict the prices for 2 days ahead from the current date. And with this, they have achieved MSE of 0.04, quite good, 0.04 MSE, and the R2 of 0.91, which is really impressive. This gives us an idea to go further with our study. The second study, which used a crow search algorithm along with the LSTM, and with this, they have a price fluctuation of plus minus 10% of the closing price. and they have achieved MSE of 0.04 and R2 of 0.91. The third study, which used a guided crew search algorithm and its variation, and they used MSE, MAE, MAPE, and R2 coefficient of determination to evaluate their model, and they have achieved R2 of 0.9983 for the currency and 0.99 for 86 for GBP and 0.9982 for the USD INR. The fourth study, which used hybrid neural network with one of the meta-heuristic, interesting mode of function, and they have RMC, which was 9.4% increase in MAPE, which surpassing the previous forecasting method. The other study, which used a particle swarm optimizer with the LSTM GRU, and this study predicting the prices of a 20-day temporal tension with a 50-day, 200-day exponential moving average, and they have achieved best accuracy of 57.64. The one more study which used stock price prediction for Indian market, and they have used WAF optimization and optimization in the arena, and even they have increased the MD matrix from 8.27 to 50%. The last study, which used a sport vector machine with the particle swarm optimization, and they have achieved 79% hit rate in their study. So this is the methodology we are following for our framework, where we collected data from the stock historical data and the BSC index. We merge both the data set on the date column, and we process it by missing the by filling the missing values. And from those, we calculate technical indicators like volatility, trend indicator, momentum, and we split the data into three parts. 80% of is our training data, test data is of 10%, and validation data is again of 10%. We feed this training data for our this attention model, transformation attention model, and where we have input feature as all the training data, and the target feature was the closing prices. And we use the multi-height attention and add and arms features to attain the temporal attention of our technical indicators data. First, once we have a target feature, we feed those target variable into model training and optimizer parameter, where we have three layers of long short-term memory, and which pass through different gator recurrent unit, epochs, batch size, learning rate, and a dropout. Which rather we are fixing those for our model training, we use particle swarm optimizers, where we use MAE, MAPE, and R2 to get the optimal hypertuning parameter of all the LSTM models. The hyperparametric tuning, we use the units, the number of units for LSTM, optimal number of units of LSTM, the batch size, learning rate, epochs, and the dropout. And then those things came from a particle swarm optimizer, and once we get it from those, and we train our model. Once model is trained, that model is now being applied on test data and validation data, and whatever the output we get, that is evaluated by using three parameters: R2 score, MAE, and MAPE. So for data acquisition, we use Yahoo Finance API, where we receive data of stock prices, the blue chip stock prices, and BSE index from the duration of April 2020 to December 31st, 2022. This is completely 4 years of data. The basic data we got is the open price, low price, high price, close price, and the volume. Then same data we got it for BSE census index, and then we fused both the data set on the basis of a date column. And once we have it, then we calculate technical indicators, and after technical indicator, we scale down we perform the normalization using the min-max scaler. This is for for experiment study, and yes, once we have a pre-processed data, so these are the companies stock prices: Reliance Industry, HDFC Bank, ICICI Bank, Kotak Bank, Infi, LTC, and Larsen and Toubro. And so we fuse both the data after pre-processing, we applied a model training. That was model training using LSTM. The range we given to our particle swarm optimizer, LSTM units, is of 32 to 128 units. Dropout is of 0.1 to 0.3 neurons, percentage of neurons. And 0.1 is 10% of neurons to 30% neurons we drop out as optimal, so to avoid overfitting. Batch size was of 60 to 32. Epochs range from 100 to 300 because of the temporal feature. Learning rate we choose 0.01 to 0.0001. So these are the results we receive from our framework. The number of training days, 1000 training day, we 1000 other temporal feature which go through the attention model, and we got accuracy of 82%, precision of 78, recall 73, and 81. But surprisingly, when we perform this thing for our 5000 training day, we got a maximum accuracy of 89. Precision was a little bit slow, 74% as compared to the 3000 and 1000 units, 1000 training day. Recall we see 0.79, which is again a maximum among all the number of training day. F score again 0.87, which is again highest among all the training days. So 5000 was the we think a good result because we have a larger temporal feature, except of a precision where we are a little bit go down, right? So this is the graph, visualized graph of our lines industry, where the black solid lines are the actual prices from 24 Feb to 25 Jan, and the red dotted lines are the predicted prices. So you can see the marginal difference is very low as compared if you're comparing both the graphs, both the lines of actual price and predicted price. So these are the results, final results, where particle swarm optimizer lines BU 128 units, and the R2 was 0.93. The maximum we got in ICICI Bank, where the R2 is the 0.98, MAE is of 3.73, MAE of 10.98. The optimal parameter which particle swarm optimizer chosen for ICICI Bank is units of 64 units of LSTM. Batch size is of 32, learning rate is of 0.001, epochs is of 200. So with this, even dropout of 30%. So with this, we receive the highest R2 is of 9.98, which is very close to 1. And the second highest was of ITCBO 97 and LT again 97, which is followed by 96 of HDFC, and Reliance is of 0.93. So although our framework is ranging from 93 to 98 for all the blue chip stocks. So at last, in conclusion, as we said, we present our steady hybrid deep learning methodology to predict the stock prices, which fuse the neural network with the meta-heuristic algorithm particle swarm optimizer. And we used a 90-day rolling period, and for short-term anomalies, the model was validated for universally on a post-pandemic, because the data we received, which include the COVID-19 period also. Although there is a very fluctuation at that period of time, but still our model achieved very good result. Although it is not being able to capture the sudden change in prices due to like the events that keep happen, COVID-19 or a big recession or Black Friday. So those kind of things, I don't think it will be having that much potential to acknowledge. But yes, our model still perform very good job. Even data set we have COVID-19. That kind of event happened, which sluggish all the prices, but still our model is performing very good. So with the R2 of 0.97, 1.67 for LT stock model, which achieves a 89% accuracy over a 5000 trading day. In future search, we feel either the reinforcement learning or some other sort of data we can have through which we can increase this R2, which we are trying to be which almost is a 0.97 towards the higher side of 1. But still we are trying our best to perform reinforcement learning, which we believe can achieve the better result. At last, these are the references through which we receive the idea to reach at this domain where we optimize our neural network with the particle swarm optimization. So we thank you all the authors who did very good job in their domain in stock price prediction using industry. So thank you.
Okay, thank you very much for your interest in the work on developing the deep learning based approach to predict the stock market prices. So, Dr. Harmajan Singh, and all the co-authors. So now let me open the floor for any question to Dr. Harmajan Singh. Let me ask a quick question. So we all know that there are many the methods or the approach to the predict this market prices. So how do you compare, like, I mean, your proposed approach with the existing approach, at least the well-known approaches? Of course, like, I mean, you have mentioned that you have achieved 89 accuracy, so quite, like, I mean, I think very reasonable. So, but still, I would like to know, like, I mean, how you compare your proposed method with the widely known the approaches.
Yes, actually, in our framework, we used a meta-restrict algorithm where it obtained the optimal epochs, the best size or learning rate. As of now, we haven't done any study which used this particle swarm optimization meta-restrict in a stock price prediction. Although there are some traditional prediction methods using a neural network which have a standard way of training the data. We just go beyond one step ahead. Okay, we will use some meta-restrict to have optimization of the better tuning of neural networks.
Okay, thank you, Dr. Harmajan Singh. So once again, I would like to thank all the authors of this the paper. So, and we are looking forward to seeing you with your participation in our future conferences as well. Okay, thank you very much.
Thank you.
Yeah. So let me now move on to our next presentation. I think fourth presentation in this session. Right. I think it's the same authors. Yes. Right. So the paper title is a movie recommendation model integrating viewers' emotional experience and TV features extraction. So let me start the recorded session. Yes, like, I mean, authors of this paper is Harmajan Singh and from the Chitra University Institute of Engineering and Technology in India. So then Chandra Prabha and Preeti Sarma from the Balamurugan Balaswamy Sivinadar University in India. So then Ahmad Al-Kayat, the Ismak University of Iraq, and Nitya Rekar Sivakumar, the Princess Noor Bint Abdul Rahman University in KSA. So let me start the recorded presentation.
Hi, this is Dr. Harmajan Singh, and I'm going to present my article with the name as a movie recommendation model integrating using emotional experience and TV feature extraction. So in this presentation, what I'm going to cover the introduction, literature review, methodology that we adopt for this study, experiment study, the result that we have achieved, conclusion, and at last the references. In the introduction part, like this study actually we are proposing a framework where we are provide the movie recommendation engine, which have data from IMDb, movie reviews, Netflix rating, and YouTube, and last Twitter. So we are using 4 data sources through which we can have our framework is recommending a movie. to their customer. And the methodology that we have adopted is to pre-process the data that we see from these sources, and we applied the BERT technique to pre-process the data, and later on we applied a bidirectional long short-term memory and a bidirectional data recurrent unit because of the long extension of the temporal attention of your data. Although these both the neural network has the potential to retain the long text data, the meaning of the long text data, and that's why we use both of these deep learning neural network. And along with that, we are using CNN, a convolution neural network with a self-attention mechanism. The framework that we are used for this movie recommendation system, we got accuracy of 93.91 with the area under curve of 0.9831, which is we believe is one of the highest AUC till date in the area of neural network movie recommendation system. Okay, in literature view, yes, we'll first review the articles from last 5 to 6 years on where the researcher have been used sentiment analysis and natural language processing in the area of movie recommendation system, where one of the study actually used both these NLP and sentiment analysis on a binary classification. And actually they used this IMDb movie database, and although the accuracy was a little bit crucial for them to be get at the acceptable level, but anyhow we got this idea from this study. The second study actually used a neural network on YouTube video recommendation system, and they used neural collaborative filtering, the conventional matrix factorization, and multi-layer perceptron neural network to achieve the accuracy result. For example, the Google Play utilizes a wide and deep framework which integrates the generalized linear models. In another study, the researchers used the sentiment analysis where they have performed the comparative analysis of their study with the other published articles and models. And yes, one more study where we got an idea of a film recommendation system. They have used a multi-layer perceptron and a tensor factorization to analyze the user watching pattern, how what sort of movie they have watched, or what genre they have like, only on the basis of that they are recommending movie. And in the last we have another study which is a cross-domain methodology, and the movies which are actually released in the cinema halls, and on the basis of that they used LDA-based TensorFlow association to get the results. This is the methodology of our framework where we have 4 data sources: IMDb, YouTube, Twitter, and one more, trader sentiments, right? So for IMDb, YouTube, and Twitter, we used BERT for text pre-processing. Then we calculate the sentiment score, and after sentiment score, we achieve the feature selection. For YouTube, we choose the number of number of views, and the comments. We club to get all the data for our feature selection. On the basis of that, we got a feature vector. And for IMDb, we again go for feature generation and trailer sentiments, because on a movie trailer, the sentiments will be different, but on IMDb actual movie, the sentiments will be different. So we club together, we created the matrix integration for the movies. So we club together all the data with one another. On the basis of that, we choose the matrices. And on matrices and the feature vector, we got it from the previous data sources. We club together and we achieve a recommended system. And that recommended system then validated by a state-of-art parameters. This is the experiment study where we have chosen the first data source as the IMDb data set. The tenure was from Jan 1995 to 2014. User collected was 1,173. Movies we were collected for 11,735. Rating we collected around, it's a very big number. Tags we collected 11 lakh size 50,000. Maximum rating we got is S4IoT25 minimum rating was for 694, average rating for every movie was 371. So this data we get it from Kaggle, where we selected 1,000 users from 1,000 films from Netflix. Yes, and this was the first data source I mentioned. I forgot to mention there. And this is the experimental study of IoT. Second data we have on Netflix. These are the statistics of Netflix and the YouTube statistics. And yeah, the simulator that we used is Adam, where we fused bidirectional LSTM and a bidirectional GRU, where we have a bird with the 24 layers, 1024 hidden layers, and 16 heads. In IoT, we have 49,582 reviews, where we split the data into 70 and 30, 70% for training data and 30% for testing data. And we use the Python 3.6 GPU to train our model. And where our step size is of 400, base size is of 120, number of echoes we have performed 100 to train our model. And this is what we have achieved during this fusion of bidirectional STM and bidirectional gator recurrent unit because of its characteristics to have the temporal attention. And we got very impressive result of 93.91 accuracy for a movie recommendation with the area under curve of 0.9831. So we compare our model with others, other mixture of models. Like the first one was the bird BE with the bidirectional STM and a sentimental analysis layer with the 1D CNN. We got accuracy of 92.32. Same way we clubbed another model with the gator recurrent unit with 91.19% of accuracy. And further then we clubbed together the bi-STM and a bi-GRU with the sentimental analysis. We got accuracy of 91.24. With this way, we again perform a BERT LE with the LSTM, then GRU, and last we have our own model, BERT with LE, LSTM GRU with the accuracy of 93.91 with the area under curve of 0.9831. So this way we are comparing our proposed framework with the other sort of alternative methods and the collaborations of neural network with the BERT, and we got very good, very much impressive result till date. And last we are concluding our study that, like as I said, we used a sentimental classification methods using BERT, and we fused the data from the four sources: YouTube, Twitter, IMDb, and the Netflix. And for pre-processing tokenization, we used a BERT, the state-of-art technique, and which is followed by the neural network. In neural network, we used the fusion of bidirectional LSTM and the bidirectional gator recurrent unit to get the final results in the recommendation system. And yes, we used Adam and ReLU activation from Adam as optimizer, ReLU as the activation function, and to categorize the sentiment analysis in the binary classification of a positive and negative. And then during the comparative investigation, we found that our framework, that is the fusion of bi-STM and the GRU with the CNN, achieved the result of 93.91 accuracy with area under curve of 0.9831. Although there are other, in the future work, yes, we are proposing that this could be a large data set where we can have this kind of fusion in a future work. And like we work on a text data, we can have some numerical data, some special data on which these models can be trained, and I hope we get a very good result in a coming future too. And at last, these are the references from where we got an idea of how they worked on this type of domain. And yes, these articles support us a lot. We are really thankful for all these researchers who did wonderful jobs in their work. Thank you. That's all from my side. Thank you. Thank you very much.
Okay, thank you, Dr. Harvinjat Singh, so for your very interesting presentation, and I'd like to thank all the co-authors of this paper. So, and now let me open the floor for any questions for Dr. Harvinjat Singh. All right. So, and so if you're interested in their work, so please contact them through the emails provided. So, and once again, so I would like to thank all the authors of this paper, and we are looking forward to seeing you with your participation in our future conferences. So let me conclude the first part of this technical session. So, and we have completed 4 presentations. So, and in the second part, we have three presentations. So let us take the break about 10 minutes. So then second part of the session, so we will start around 3 p.m. Okay, thank you very much. Hello everyone, so good afternoon. So let us proceed with the second part of the technical session 6 on emerging IoT applications. So we have 3 presentations scheduled for the second part of the session. So let me now cordially invite Ms. Shalini Kumari. So yes, again, so this presentation also done through the recorded video. So let me start the presentation on IoT for next generation network, succinct review.
Good evening, I am Shalini Kumari. Today I am presenting a presentation on the paper of IoT for next generation network review, and my paper ID was P25. These are the author name as shown on this slide. Next slide shows the content of the slide. That is the first slide content. In the content shows the first, that is abstract, then introduction and other parts, and then next we show the abstract of this paper, the analysis that predict that over half a trillion Internet of Things devices will become connected during the next decade as the automotive sector strive to enhance the 90% of their vehicles through IoT capabilities. And we can say that the vehicle market surpassed 250 million units in 2020 with a 67 growth rate. And also in the abstract part, we say that integrating IoT technology into industrial operation that creates the new business prospectus that let organization advance their methods and achieve optimized operations. And basically this paper presents the 6 essential factors for the IoT, and that includes the identification protocols and calculations functionalities for IoTs and operational boundaries, and the IoT leads the industrial operation into the transformation, while research between the engineering and the social economic to develop the technology of the connected system. Next slide shows the introduction of this paper. In the introduction part shows the next generation network, also known as the NGN, refers to the transition of fixed and mobile network infrastructure from the separate proprietary systems to unified networks utilizing of the internet protocols. And we can say that the internet connected devices count will grow significantly because researchers expect every device to become web enabled by 2025. And the Cisco research predicts the IoT will reach half a trillion objects by the 2030. As we can say that the six IoT components that include the identification method, sensing, communication, computational devices, and semantics. As the figure 1 shows the IoT components, these are the six components that are used in the IoT. First one is the identification, then second one is the sensing, third one is the communication, and then computation services and semantics. These are the IoT components as shown in figure 1. Then next one is the next slide shows the literature review. Basically, in the literature review, the smart devices functions best with the IoT because it enables the connection between the dynamic entities to acquire multiple forms of the environmental data, and implementing the automation technology together with the information system that merge with the malfunctioning execution system and enterprise resource planning, that is ERP, that helps to the organization to achieve the higher accuracy and productivity through connectivity. Next, that is the in the literature part, while we are using the data acquisition is the basic function of IoT operation that evaluates this through integration information analysis. Then next one is the 5G architectures in IoT, as shown in the figure 2 that shows the 5G IoT architecture in this presentation, or the figure 2 that illustration show the architecture of 5G system in IoT. As we can say that a 5G IoT framework presented in which offer the smart IoT sensors a way to connect using the various wireless and wired network until they reach the gateway. The scientist that requires the research solution to achieve the universal communication, which motivates them to study network mobility and mobility coverage and reachability. In this figure 2 that shows the 5G architecture of this, then it shows the first part of this 5G architecture, 5G care of network. Then next layer shows the cloud storage, and then next one shows the intelligence and analytics, then IoT gateways and IoT devices. This figure shows this basically first layer, that is the IoT devices. It is used for the end user devices that collect the data. Second layer, that is the IoT gateway. It uses for the bridges between the devices and the network. Third layer, that is intelligence and analytics, use the data processing and insight of that generations. And then fourth layer, that is the cloud storage. Basically, cloud storage is the scalable for the data storage and the solution. And last layer, that is the 5G core network. Basically, it is the central hub for the connectivity and data management. Next slide shows the impact of 5G on IoT. We can say that 5G is the upgradation of 4G, and in the IoT there are so many possibilities in the creative of the 5G, like lower latency, faster speed, and more capacity of 5G will enable fresh and creative IoT applications. Then, by enabling more devices to be connected to the network, then the 5G higher speed, lower latency, and greater capacity that will assist in minimizing the IoT cost. In the table 1 that presents the 5 major technology. First, that is network slicing, which allows the physical physical network slicing, which allows the physical network that divide into virtual segment. Edge computing, which process the data near its origin rather than its central cloud location. Then AIML driven network management, which uses the artificial intelligence to optimize the network, and so on. As the table 1 presents the technologies with the descriptions and implementation. First, that technology is used in this, that is network slicing. In the network slicing, one physical network that can be divided into several virtual network segments, and in its implementation, the network uses the dedicated virtual network and it slices into the serves the variety of IoT which use the use cases including massive IoT and critical IoT. The next technology is use the edge computing. In the edge computing, data processing occurs near to its origin points instead of moving data with the central location. And in this implementation of edge computing, it uses the data processing that occurs near to its origin point instead of moving data to central cloud location. The next technique, that is AIML driven network management. Basically, the application of artificial intelligence application that leads to the optimized network operations systems. Then in this implementation, predictive maintenance performs analysis alongside in the anomaly detection, while intelligent traffic routing creates efficient routes. Then software defined networking, that is also used for, also known as the SDN, and in this implementation and control operations need to remain the independent for forwarding data operations. And for the in this implementation, IoT devices manage the centralized controller for traffic engineering. Then last one is the block chain for IoT. In the blockchain, IoT description is used as the distributed ledger technology is used for the IoT interaction under the security, and for the implementation, smart contracts for the data integrity and device authentications are used. Next slide shows the applications of smart IoT for next generation. Basically, the applications of IoT that extend the across multiple domains that involve real-time multimedia and IoT-based healthcare system, along with IoT-based next generation smart industry and IoT next generation smart agriculture. As shown in the figure 3, that shows the application of smart IoT, as it shows the first, that is the smart industry. Basically, the smart industry, it is the development of the smart industries has established the fundamental lasting result for the unavoidable advancement towards the global manufacturing. As we can say that the industry 4.0, that is the cyber physical technologies, all smart industry components were unified to achieve the advanced system for high performance and quality alongside operational control management, etc. Next one is the application, that is the smart healthcare. Basically, the healthcare market actively adopt the IoT technologies in its commercial operation. Several businesses solution operate in the healthcare sector to provide these services to individuals. Then next application, that is the smart cities. In the smart city, the IoT systems has enabled the creations of specific arrangement that are used indirectly or indirectly to establish the relationship between various applications for smart cities, etc. Then The next one is the smart cities cover in this, and the other applications are used in smart cities. Several sensor devices present the drawback when they malfunction because of their failure mechanism. Then smart homes also the application for this next generation in the smart homes. Energy management is used and home security is managed by this. The smart transportation is also the application. In the smart transportation, connected vehicles, how they connected with each other, and logistic optimization is used in the smart transportation. Then next slide show the challenges and implementation. In the challenges and implementation, basically a large number of problems halt the smooth integration of IoT into the next generation networks despite existing positive development. The table 2 presents the challenges in implementations IoT for the next generation. Table 2 is that encounters the challenges. In the first column that shows the challenges and second column shows the description of that. First challenge, that is the scalability issue. In the scalability issue, it is the extensive deployment of IoT devices which result the huge data productions which needs the strong and adaptable network infrastructure for the efficient communication and processing. Second challenge, that is the security and privacy risk. Basically, the Internet of Things that exist against several type of cyber threats, which include the data breaches combined with unauthorized access, etc. Third one is the latency and real-time processing. Basically, many IoT devices needs the real-time data processing because of the healthcare monitoring requirement and needs for the driverless cars. The next challenge is that is the energy consumption and sustainability. Basically, it requires the energy efficient communications system that operate on the IoT devices and depend on the battery power. Then last challenges that occurs in interoperability and stabilization. In this the challenge, the multiple IoT devices that use the different communications method that cause the capability problems. And then the next slide show the conclusion and future scope of this paper. Basically, business industries experience the significant transformations because of the IoT technology strengths their operational method and resources management system. Basically, organization that employ on the IoT solution established improve the business process coordination and better decision making technologies. Smart agriculture that gains the significant benefits from the future application of IoT because of these technologies require additional development or to improve the power consumption efficiency because the developer that construct adapted IoT system with the extensive deployment opportunities across different industrial field. Then these are the references that are used in this paper. After that, these are the references, and thank you.
Thank you very much, Ms. Saloni Kumari, for your very interesting presentation on the review on the IoT for next generation networks. So let me open the floor for the questions. Okay, so let me ask quick questions. Like in your presentation, you have discussed like some of the technologies, right? So and the 5G, so and how they impact on the evolution of the future IoT the networks. I would like to know, since you have discussed about the application of the IoT in agriculture sector. So, for example, like how edge computing would impact on the smart agriculture, like IoT based smart agriculture. So can you please calibrate on this?
Yes, sir. Basically, edge computing significantly impacted to the smart manufacturing agriculture by enabling the real-time data processing, the analysis at the farm level, leading to the improved decision making.
All right. So I would like to express our the sincere thanks for the Ms. Saran Kumari and all the co-authors for their presentation on the IoT for next generation network success review, and so we are looking forward to your participation in our future conferences as well. Okay, so thank you very much once again.
Thank you so much, sir.
Yeah, so then, so let me move to the next presentation. So this is, I think, the sixth presentation on this session. So, and the title of this paper is an optimized learning framework for stock market, the prediction using multi-source data and gray wolf optimizer. So I think once again, I would like to invite, of course, Dr. Harmajan Singh. So let me start the recorded the video.
Hi, this is Dr. Manjeet Singh, and I'm going to present my article. The title name is An Optimized Learning Framework for Stock Market Prediction Using Multi-Source Data and Gray Wolf Optimizer. The content I'm going to cover in this presentation is the introduction, literature review, methodology that we have adopted for this research study, experiment study, conclusion, and the last, the references. So in introduction, the proposed system that we have proposing in this study is a hybrid LSTM model for stock price prediction, which used a meta-heuristic optimizer as a gray wolf optimizer. Although there are other meta-heuristic optimizer. One of those are like artificial optimization, which used by many researchers for their study to predict the stock prices using meta-heuristic optimizer. Particle swarm optimizer, salt swarm optimizer, equilibrium, there are many weight optimization algorithm, Harris-Fox optimization, and yes, in our study that we used a gray wolf optimizer. The model the framework that we have proposing over here is evaluated by the state-of-art parameter. We used accuracy, coefficient of determination as R square, mean absolute percentage error made, and the last we used RMSE, that is a root mean square error, to evaluate the actual and the predicted price by the framework. Why these meta-heuristic optimizers are come into picture in today's environment? Because it use the optimal number of epochs, batch size, learning rate in a neural network to train the models. Although earlier we used the fixed size of the neural networks, layers, epochs, batch size, learning rate, even the dropout rate. So that we actually make our system a little bit rigid. So to optimize those things, we use meta-heuristic, the nature-inspired algorithms. Some of them we have here is which categorized into three categories: evolutionary based, like a genetic algorithm, physics based, and swarm based, like particle swarm optimizer and ant cloning. These all are nature-inspired and meta-heuristic optimizer, which replicate the working mechanism of ant and swarm. This way, they replicate the neural network to train the models. Although there are many others also like a Groovon Sound Optimizer, Cuckoo Search, and Artificial Ecosystem Based Optimization, they all are nature inspired optimizers, which mix with the neural network to train the framework on any domain. So this is a literature. The first study which introduced the hybrid deep learning neural network, which used GRU and LSTM, and they used Golden Jackal optimizer, and they optimized the batch size and the dropout to tune the LSTM and the GRU layer. With this, they got RMSE of 0.798, and which is considerably good RMSE. And they split the data into 70 and 30. 70% for training data and 30% of their test data. In second study, which used a hybrid model, Gator unit, and they used artificial optimization and to predict the stock prices. And with this, they have achieved MSE of 81.8%, NAPE is of 64%. They used the Apple stock data for this, and the R2 was 5.3. In another study, the author used a fuzzy scored vector regression and with a grave of optimizer, and with this the NAPE was at 3.12, RMSE was 4.12. Likewise, another study, GWO, is used with the Garcher Arena for time series models, and they achieved RMSE in a different Indian stocks. Further, one more study which used a scored vector regression with a slime mold algorithm, and they used although they used a Grey-Wolf optimizer, and they have achieved the mentioned state-of-art parameters results. So with this, there are many studies which use many meta-heuristic algorithms for the stock price prediction. This is a methodology for our framework. We use data collection from the two sources. One is for data of historical data of stock. The second one is the index data, BSC. We merge the data on the basis of grade carbon. We pre-process the data and the filling missing value using a backward fill or forward fill approach. Then we calculate the technical index on the basis of volume, trend, volatility, and momentum. Once our data is pre-processed, we divide the data into 80 and 20%. 80% for training and 20% of our test data. On training data, we used hybrid layers of LSTM, 3 layers of LSTM, which flatten the output. And then we train on the model. The model training actually came from the Grey-Wolf optimizer, where the Wolf, we used 10 Wolf, and on the basis of that, we compute the RMSE, MAPE, and R2 scale, coefficient of determination, and accordingly we update the position of Wolves. So once the criteria match, okay, then we forward those parameters like batch size, epochs, learning rate, dropout, and the number of layers. We forward those selected parameters to our model training hyperparameter tuning, and once model training is complete, we apply our test data to test the predicted price, and those predicted price we compare with our MAE, MAPE, and R2. So this is a data we have. We have two sort of data. One is the stock data, one is the BSC data from the year April 1, 2020 to 31st March 25. And technical indicator, we use RSI, Bollinger Bands, and MACD for this. These are the ranges of our hyperparameter tuning for a Grey-Wolf optimizer like LSM unit. We mentioned 64 to 128, dropout 0.2 to 0.3, batch size 32 to 64, epochs 100 to 250, and the learning rate was 0.01 to 0.0001. So these are the ranges we give to our Grey-Wolf optimizer to choose the best one. And this is the experiment study where we have, this is the graph of our license industry, the open price, high price, low price, and close price, and the volume from the April 2020 to March 25. And we got this data from a BSC index. Same way we have a BSC.VO, the same data we have for our index data from April 2020 to 31st March 2025. And this is the result. Once we club together both the data indexes like stock data and BSC data, so we got, this is the result where the red solid lines are actual prices and the dotted green lines were the predicted lines which actually obtained by the framework. Although the difference is minimal, but this is how actually it is visualized. These are the results of because we performed this framework on around 7 tickers, the blue chip stock of BSC. And these are the results where the lines, where wave-off optimizer predict the price of our lines for the units of 128 layers of LST and dropout of a 0.3, learning rate of 0.001. And we got the maximum result R2 of 0.96 in area in the case of our line. Same way for TCS, we got a 0.95, HDFC of 0.95, and last we have LT of 0.93. We can compare our baseline model with the mean CI and LSTM CI, where we have the differences of 0.004 to 0.002, and all the p-values are less than 0.001, which is significantly best. I would say this is the t-test which we applied on a 30 independent trials, and the 95% confidence interval we achieved for all the 7 stock, and the significance is almost yes. And so we would claim that we in our framework did pretty good job in all the state blue chip stock prices. And yes, in last we have a conclusion. As we said, we used multi-source financial data for LSTM, and we optimized using a gray wolf optimizer. And in this we got a very good result, where we have a model accuracy went from 92.3 to 94.8. 94.8 was in a nice industry. In almost all the ticker we got a significance value which is less than 0.01, and it is a consistent in every stocks. In future, we are recommending Bison deep learning, where we have some dynamic data or non-linear data, some reinforcement learning we can apply, which we hope can give a better result than this tool also. And at last, we have these are the reference from where we got an idea to perform our to build our framework with the Grave of Optimizer, using a stock and index data. So we really thankful to all these researchers who did very good job in the area of meta-heuristic algorithms. That's all. Thank you. Thank you.
Okay, thank you very much once again, Dr. Hamidan Singh. For your very interesting presentation. So, I think this is your third presentation in this session. So, let me open the floor for the questions. All right, so if you have any questions, so please contact the authors, like via email. So let me thanks on behalf of the organizers, all the authors of this paper. So let me now move on to our last presentation in the session, which is on the farmer-friendly AI-powered smart agriculture loan appraisal system by considering their land yield capacity. So the list of the authors are given. So I think a presenter would be Ms. Vusulata Naveen Kumar. So let me start the video. So
our paper ID is 39. And the paper titled A Farmer-Friendly AI-Powered Smart Agriculture Loan Appraisal System by Considering Their Land Yield Capacity. And the content, what we are going to see in our presentation are abstract, introduction, followed by proposed methodology, modes of operation, how hardware systems is in our project, technological integration, validation, and conclusion with the reference what we are referred to complete our project. Coming to know about the abstract, agriculture is an important industry that facilitates economic development, empowerment, employment, and food security. But financial constraints frequently hinders farmers from embracing advanced farming methods, which results in decreased productivity. So, various agriculture loan schemes, their contribution to increase farming productivity and the difficulties farmers encounter is updating financial support. The research also investigates various loan schemes comparing government guaranteed loans, private sector lending, and online lending platforms, improved accessibility and efficiency in farm financing. The results highlight the necessity of policy changes, financial education initiatives, and the inclusion of digital marketing technologies to improve the access to loans and enhancing the repayment system to ensure the sustainability farm development. Coming to know about the introduction, farmers and a farmer is a major contributor to GDP and rural livelihoods. Agricultural financing is necessary because of the unpredictable weather patterns, volatile market prices, and the high expense of advanced farming methods. Agriculture loans supply required funds for the purchase of equipments, seeds, fertilizers, and other inputs to raise productivity. Government policies, banking systems, and microfinancial institutions have an important role to offer affordable and accessible agriculture loans. Tight collateral requirements and long approval times, poor financial literacy, long rural farmers also impediments their capacity to access and manage loans successfully. This paper discussed agriculture loan systems, their effects on farmers, and the difficulties in enhancing such loans, as well as possible enhancement and innovation in agriculture financing. So coming to the proposed methodology, we have two types of things which is used in our project, which is hardware, and another part of the project is the software. In hardware, we are using pH level of soil sensor, salinity sensor, temperature sensor, humidity sensor, and soil moisture sensor, which can be controlled by the basic and main controller, which is called as microcontroller. And in a software side, weather data, which is fetched by APIs, human machine interface, which is a website working as an intermediate building between the human and the machines. Last one is artificial intelligence, which is integrated with the machine interface, which is used for making the work very easy. These two things are then connected with the fire-based cloud system. In this, we are using AWS and we can able to use all those cloud systems. This is a method proposed in our project. Next, coming to see the mode of operation, we have two modes of operation. First one is application submission mode. In this, we can see the board which the cost of a loan is calculated with the interest, and it was displayed in the screen with all those details. In the second mode of operation, we have the eligibility prediction using a web application which we have integrated it with Blink app, and we can able to see all those readings lively in our mobile phone itself. Is an overall advantage. We can able to see all those real-time examples and the readings in mobile itself. Then coming to the hardware model, prototype farmland with sensor monitoring, soil wetness, climate, and crop health to help set loan payment schedules aligned with farming goals. This approach offers a semantic framework for accessing the performance of agricultural loan systems, determining the challenges and suggesting the improvements for enhanced financial inclusion and agriculture sector sustainability. It was a small prototype which was developed by us to check how our system is working on. Then the technological integration in this, we have a type of loan schemes which is government subsidy loans, and the average amount of the loan is 75,000 with an average yield increase of 25,000 and a repayment of 82 percentage, which has an application time of 15 days. Like this, there are the private bank loans which the amount given by them was 1,20,000 with the increasing in yield of 18 percentage, repayment rate of 75 percentage and application time of 10 percentage of days. Next, we have another two loan systems which is cooperative loans and digital lending apps. This was the comparison of agriculture loan schemes and their impacts. Coming to now the validation, we have validated based on the 100 farmers data shown in the table. The farmer ID is the ID which was given by the individual farmer with the actual yield and the prediction yield with the error percentage. The OLS analysis will provide 91% of accuracy and MAE of 1.42 tons. A pilot simulation had even given 64% of saving in this processing time. Coming to the conclusion, agriculture credit is important for the assistance of farmers throughout the provision of financial buying, crucial inputs, enhancing the productivity and reducing the risk of the farmers. Conventional systems of the loan tend to have the obstacles like drawdown approval procedure, straightened collateral requirements, and restricted accessibility for substance farming. Improving the efficiency, lower the chances of defaults, and enhancing the financial inclusion for farmers. So, our working model is doing these things to be enhancing the farmers' yield and also the loan predictability. So the study underlines the role that technology can play in an agriculture financing. Future studies could aim to expand the capabilities of AI, refining the risk assessment model, and develop better financial literacy programs to promote sustainability agriculture development. So these are the reference which we had referred like IEEE 24th International Symposium of Design and Technology in Electronic. Like this we had referred so many of the reference papers for check the productivity and the sustainability of our project and the validation of our prototype too. These are the additional reference links what we have referred still now to complete our project prototype hardware model. If you have any queries, please feel free to ask us and thank you.
Okay, thank you, Ms. Futsalata Naveen Kumar, for your very interesting presentation. So, integration of the AI-based the technologies in agriculture. So let me open the floor for the questions. So, let me ask a quick question. So just actually this is just for my own clarification. So I would like to know, like, I mean, what are the things that you can predict? Like, I mean, it's a yield, or like what are the other parameters that you would be able to predict using your proposed the system?
Okay, so we can able to predict the weather and the yield of the farmers, as well as how much yield they can able to make and how much loan they can able to spend to the bank or else some of the government criteria which are providing the loan for them, sir. So it is very useful and it is very crucial product for the farmers to make the or repay the amount which they have as a loan amount.
Yeah, but one thing, like, I mean, this your proposed system help to obtain the loans, like upon the ongoing cultivation, right? Like, I mean, if they want to get a loan, like, I mean, in advance for the, I mean, what they plan to the grow. So, what do you think in that case also it would be helpful or?
Yes, sir, of course, that in that case also it going to be moving on, and it is helping the farmers to make or retain the loans to the government sectors.
All right. So once again, I would like to thank the Ms. Pushpalata Naveen Kumar and all the co-authors for your interest in the study and also presenting the paper today. So, and I think we come to the end of the session. Yeah. So in this session, so we had like, I mean, altogether 7 the papers, and all the papers are presented online through the recorded videos. So, and so I would like to thank all the authors and presenters today. And so on behalf of the organizing committee, so I would like to express our sincere thanks and considering to publish at our conference, right? So your very valuable research. So, and we are looking forward to your participation in our future version of the conference. And so I'd like to thank all the audience as well. So let me conclude the session. So, and have a nice day. Thank you very much.